Assalamu alaikum. In this video we will model, analyze and design a steel pedestrian bridge. So here is the plan of our bridge. You can see that there are 9 grids in X direction and 2 grids in Y direction and also 2 grids in Z direction. The spacing between grids in X direction is 4 feet and the spacing between Z direction is 3 feet. First we will model that pedestrian bridge in SAP 2000. To initiate the model, we first go to the file command, then we select new model. A pop-up will appear. First we have to choose default units. For example, if we drop down, then we have multiple options like pound, inch, Fahrenheit. If you want to work in SI units, then you can select SI units. So we will work in pound, feet and inch. Default materials, so we will select United States. We will select template as grid only. Then we will put our grid data and grid spacing. So we will insert there. We have 9 grids in X direction and 2 grids in Y direction and 2 grids in Z direction. The spacing in X direction is 4 feet and the spacing in Y direction is 8 feet and the spacing in Z direction is 3 feet. So our model will initiate from the origin. So we will keep these things like first grid line location on X direction, Y direction, Z direction 0. So this window appears. Here is XY plane and here is 3D view. We can rotate into different views like an XY view, XZ view and YZ view. So if we want to work in elevation, then we will have to select XZ plan as it is shown in this. So first we have to define our materials, then we have to define our section properties, then we have to define our deck or floor system, then we have to define the load patterns, and then we have to define the load combinations, then we have to then we will model the bridge according to the drawing. Then we have to apply the loads and then we have to run the analysis, and after analysis we have to select the design criteria, design combinations, and then we will run the command of the design. So it will show whether our selected members pass the design criteria or not. So we will initiate by going to define materials. Since our pedestrian bridge is made of steel, so we will define material as a steel material. So this is the command of add new material. This is steel. So we will select ASTM A36 grade 36 steel. So we can remove all other material if we want, which are predefined. Now we have to define section properties. So we will use, so these are the member of frame, so we have to add new property. For the bottom chord and for the top chord, we will select wide flange I section, and for the inclined members we will select angle section. So first we will define the top chord and bottom chord. We will select this I section, we will rename it as bottom chord. So here material A36. If we want to see the section properties, we can click on the section properties. Here we will have different parameters of the sections like moment of inertia about X direction, Y direction, and radius of gyration about X direction and Y direction, and other modulus, section modulus, shear center. All these properties we can have from this property data. We'll hit OK. So we will have same top chord and bottom chords. We'll copy this property, add a copy of the property, and we will rename it as top chord. And hit OK. Then we have to define the inclined members. So we'll add a new property. We'll select angle section for the inclined member. So here we write section name as inclined members. material E36. Okay. Now we will add vertical members. We will select again I section for the vertical members, vertical posts. Again the material is A36. Press OK. Then we have to define the floor beams. A new property. Then again we will select divide angle. Rename as that floor beams. That's okay. Now all the material and the section have been defined. Now we will not design the deck, but we will to apply the loads. So we have to define the deck. We will go to section properties and area sections. Here we have to select shell, create new section. So this is shell thick, and material we will use A36. We don't have to design the deck, but to apply the load for our ease, we'll just draw this deck. So section name as deck. Now we will model the structure. So we have different drawing tools like draw special joint, draw frame cable, quick draw floor cables. So we'll select draw frame cables. Now we are working in XZ plane, which is elevation view. So here we will select, first we will draw bottom card. So section is bottom card and moment release is continuous. One thing we should make sure before modeling any truss, that this moment release should be pinned. If we select continuous, then we have to release the moments from the section properties. So first we will moment release, make it continuous, and we will start drawing the numbers. We'll start from the origin and keep. After one number is drawn, we'll press enter and then initiate. Similar pattern we can draw all the numbers. We'll draw only first one truss and we'll replicate this truss to the other grid. So we have drawn all the bottom chord members. Now we will select the top chord. Now we have drawn top chord as well. Now we will draw in vertical members. All vertical members have been drawn. Now we will draw the inclined members. As you can see, we have drawn all the members of the truss. Now we will assign supports. On one side, on the left side, we will assign hinge support, and on the right side, we will assign roller support. So first we select the joint, then we go to assign joint restraints, and here, and the second is the hinge. So we will apply the hinge here. Now we will select the extreme right joint and assign roller support. Now you can see all the supports have been assigned. Now we have to release the moments. So we will select all the joints and go to assign and frame and release partial fixity. Here we have to release these moments M22 and M33 moments in both axes. We'll apply and hit OK. So now you can see that all the moments have been released. So now we will replicate this truss. So if we see that in the 3D view we have our truss on grid number 2 in y direction. So here is our origin. So we have moved 8 points from the origin, since the spacing between the y grid is 8 feet. So if we want to replicate this truss on grid number 1, so we have to move back -8 units with a minus sign. So first we will select all the truss from the elevation view, then we will go to edit and we will hit the command of replicate. Simply we can activate the replicate command by pressing Ctrl plus R. Now we have to move -8 units in y direction. We'll enter -8 and apply and press OK. You can see that our truss has moved to grid 1. Now we have to draw the floor beams and deck. For this we have to go to the XY plane and we are in XY plane. We are in top story, we will come to the bottom story. Then we will select the draw frame cable command, and here we have to select the section which is floor beams. Now we will draw the floor beams. You can draw one and replicate all others. We have drawn all the floor beams as you can see in 3D view. So now one thing is left, which is deck, so we have to draw the deck. We will select draw poly area. We have multiple options to draw the area, so we will select the poly area. We will select our section which is deck. We select this point, extreme right upper corner, extreme right lower corner, extreme left bottom corner, and again from where we started. So clicking enter, we have drawn the floor. Now you can see that only a red line appear. So if we want to see our floor, then we have to go to set display options. From here we have to go to the general options, and from general we have to check this fill objects option. So if we check the fill objects option, then we can see the floor deck. Also from view type we have to shift to the extrude view. You can see the extruded model. Now you can see that we can see the floor in our XY plane. We want to do same for the 3D view, and activate the 3D view window and go to the check display options, general options, and apply these settings to 3D. Now you can see the extruded view of the members and also the deck. You can rotate to view all the details. Now we have to define the load patterns and load combinations, and then we have to assign the loads and run analysis. So for this we have to go to define load patterns. We have dead load, self weight multiplier factor 1. If we want to calculate the self weight through software by itself, then we have to make this self weight multiplier factor as 1. But if we manually want to apply the self weight, then we have to make this self weight multiplier factor as 0. So we will make it as 1. We have to define the live load, which will be due to the pedestrians. From here we can select the type as live load and we'll add new load pattern. So we have two loads, dead load, live load. We can add other loads like seismic loads, earthquake load in X direction. We will define EQX. This is type of quick load pattern. We will select And there are multiple options building code from where it can automatically calculates the loads based on the soil type, seismic zones, and importance factor and overstrength factor. So we will select UBC 97 and add new load pattern. We have to modify the lateral load pattern since we have only checked earthquake in X direction. We will select modify lateral load pattern. So make sure it will check global X direction. Other parameters like the soil profile, seismic zone factor, seismic source type, overstrength factor, and importance factor. And these are provided by the any building code. So here we will select the soil. For example, let's say our soil profile is SP. Our seismic zone factor is 0.3. We can define seismic zone factor. So if we define the seismic zone factor, then it automatically fetches the seismic source type, and we have importance factor of 1 and overstrength factor of 5.5. let's say we'll hit OK. Similarly, we can define the earthquake in Y direction. So add new load pattern, then we'll go to modify lateral load pattern, and we will check now global Y direction. And other R properties SB 0.2 and this overstrength factor 5.5, and remain the importance factor as 1. Now we have defined the dead load, live load, earthquake load. So we'll press OK. Now we have to define the load combinations. There are two options: either we define our own load combinations or add default load combinations. So SAP 2000 has different load combinations which have options of steel frame design, concrete frame design, aluminum frame design, and cold formed frame design. So if we select steel frame design, it will have these built-in load combinations. But if we want to define our own load combination, we can also define it. So we'll go to the UBC 97. So we have different load combinations like 1.4 dead load, 1.2 dead load, and live load, and other like this for the seismic design 0.9 dead and 1.0 earthquake load, or 1.2 dead and 1.0 earthquake load. So we'll define different load patterns. So here add new combination. We will name it as 1.2D plus 1.6 L. So here is scale factor for the dead load is 1.2. Here is dead and scale factor is 1.2. We'll add, and we have live load and scale factor of live load is 1.6. Add. Okay. Then we can also define other combination like from the UBC 97 as 1.2D plus 1.0 EQX and EQY. So 1.2D plus 1.0 EQX. We will have load as dead load, and we have scale factor of 1.2. Then we have EQX, and we have a scale of 1.0. So this is our new load combination. Similarly, you can define multiple load combinations. We'll press OK. Now we have to apply the loads. Loads are also defined by different building codes, and for the bridges there are guidelines of LRFD and AASHTO guidelines for the pedestrian bridge design. So we'll assign loads. We'll go to, since we have to apply the loads on the floor, so we'll select the area loads and gravity. Now we will select the floor. We will apply the loads in global Z direction. So first we apply the dead load. Let's say we will apply 40 pound per foot scale, since we are working in pound, feet, and Fahrenheit. So we'll select 40 pound per foot scale and apply the load. So we have applied the dead load, and this is 40 plus 40, so we'll have to first we'll check add to existing load. Since we have to apply this load in downward directions, we will select minus 40. Again select the floor, apply. Now we select the live load and select as -100. Then select the floor and hit apply. Now we have applied the dead load and live load. The seismic loads, the software calculates itself according to the building code. Now we have to check the model for any error. So we'll first check the save the model. Name it as truss pedestrian. So our model has been saved. Now we will have to check the model. We'll go to analyze. You can set analysis options like available degree of freedoms. If we want to have a 3D analysis, so on one node we have 6 degree of freedom. If we want to have a 2D analysis, we have 4 degrees of freedom on one node. So it is our desire whether we have to analyze the structure for 3D or 2D. So we'll check all these 6 degree of freedom since we want to analyze this model in 3D. So we'll press OK and we'll run analysis. So here is the options: dead load, model, live load, earthquake X, earthquake Y. We will run all these cases. So we will select run now. So it will checking the model and preparing to analyze. So here is the analysis. You can show that there is in this window you can see a deformed shape. So you change the view to in XZ direction, you can view the deformed shape under dead load. If you want to see deformed shape under any other load, you can click here, or we can go to the display window and show deformed shape. We'll select, for example, we want to see the building's bridge response in earthquake X direction. We will select this load earthquake X and apply. Where is the deformed shape of the truss in earthquake X direction? If we want to check the response of the bridge in live load, then we will select the case as live and apply. Similarly, you can, if you want to check the building response in any other load combination, we'll set apply for this combination. Close. If you want to show different diagram like axial force, since we have only axial force in our truss, we will show axial force. Fill the diagram and hit apply. So it is the axial load in the members of truss due to dead load. If you want to check the value of any member, we can simply click on any portion, just bring the cursor on the portion, we will show the value of the axial force. So the member which have been filled as red are in compression, and the member which have been filled as in blue color are in the tension. Okay. Now we will select the design combinations. So we have to go to design, select the design groups. Here we will select all design groups and hit OK. Now we will go again design, steel frame design, view and revise preferences. So these preferences are based on AISC 36016. This is our design code. If we want to modify any parameter of these specifications, we can change it by just clicking and editing. Since we don't have any modification, I will press OK. Now we have to select the design combinations. So we will design for 1.2 dead and 1.0 earthquake X. We will add this combination. Okay. Now we will set displacement targets. If we have any serviceability limits for any load, we can set the lateral displacement targets. Press OK. When we go to design, steel frame design, start design check. If we want to view the results of the design in 2D view, when we select XZ, you can see that all our members have been passed. If we want to check the details, we can simply click on the member. A pop-up will appear, then we will click on details. So here are different details. You can see for this member, the axial force is 1302 pounds, which is in compression, and the member's capacity is 192,889. So you can see that our capacity is greater than the demand, so our member has been passed. So if after checking the design, if any member gets failed, so we have to revise the section and again analyze it and again check the design conditions. Now we will select go to design and display design info. You can stack different parameters, maximum stress ratios, and press OK. So here are the maximum stress ratios of the design. So for verify analysis versus design sector, so our analysis and design section match for all steel frames. We want to verify all member passed, and we will click verify all member passed. So in this video we modeled, analyzed and designed a steel pedestrian bridge.